Today we will be covering the reactions of benzene. So before we start with the reactions of benzene, benzene is stable. All right. So what contributes to the stability? It is actually due to the localization of high electrons in the ring. Okay, that gives the aromatic stabilization. Okay, so first you need to know that benzene is being a stable compound, all right, because they have this aromatic stabilization. It's a form of energy. So when a compound is stable, it means that it will not react easily most of the time with another compound, all right? And therefore, if you want to react with a benzene ring, in general, perhaps you may need a catalyst to facilitate. Perhaps you need to heat it up to increase the rate, or perhaps you need to use concentrated reactant in some ways to help benzene react in the manner that you want. Okay, so that's the first thing you have to consider. Okay, so I always associate stability and benzene ring. Okay, only benzene ring. I did not mention about any other things after you have put on the ring. Okay, but if just an empty ring, it is stable. Okay, now the first reaction that we're going to cover today is called halogenation. Okay, so we want to form for example, chlorobenzene. Okay, so I will write here number 1. Okay, halogenation, and I'm going to write here halogenation. Now, what do you need over here? You need your Cl2 gas, and you need your AlCl3, which is a catalyst. So that is the first thing you will form. Okay, now the small information I'll write down here. Okay, how do we balance an equation for the halogenation? So we first put a ring and chlorine. With the help of your AlCl3, it will give your chlorobenzene and HCl. Okay, yeah, so that is the first reaction. The second one is called nitration. Okay, so I will drag an arrow here. Second one is called nitration. So you will form a nitrobenzene. Okay, now if some of you are questioning why I put the chlorine at, the northeast direction, or maybe the 2 p.m. direction, or why do I put the nitro on the 12 p.m. direction or north direction? Actually, you can put anywhere because that position will be position 1. Okay, yeah, but I just want to give a little bit of variety. Now, therefore, what do you need? You need concentrated. Do you see now? Concentrated reactant is being used, and you need a catalyst, which is your concentrated sulfuric acid catalyst here. Temperature-wise, we will always propose 55 degrees Celsius, anywhere from 50 to 60. We'll pick the middle one. Okay, now, even though the syllabus for 2022 to 2024 allow 25 to 60, but we will normally pick 55. Okay, so second is called nitration. Can we construct an equation for this? Ring and HNO3 and H2O. Okay, so in between, you need a sulfuric acid to help and a 55 degrees Celsius here. Okay, that is a balancing equation part. Okay, now from first equation, which is halogenation, and the second one called the nitration, right? If you look at the reagent and condition used, you realize there's something repeating here. Catalyst. First one require an AlCl3 catalyst. Second one also require a catalyst, but it's a concentrated H2SO4. Okay, so now do you realize that benzene is stable and they require some form of assistance to help the reaction to run? So in this case, you see catalyst is involved for the two reaction. But of course, nitration involves more so-called assistance where you need concentrated reactant, which is HNO3, and you also need heating for this step. Okay, yeah. So this tells us repeatedly that benzene being alone is a very stable compound. Why? Remember on top? Due to the aromatic stabilization that was caused by the delocalization of the pi electrons in the ring. Okay, now number three. Number three is called Friedel-Crafts Alkylation. Okay, so I'm going to drag an arrow here. Okay, now it's a little bit too long to write Friedel-Crafts, and I don't think Friedel-Crafts is necessary. You can just write alkylation. What is alkylation? Alkylation means you put an alkyl group. Maybe I should modify my example. I don't want to put CH3, too boring. Most of the books will tell you this. I would like to prolong the chain and put an ethyl group. Okay, this is also an alkyl. All right, so alkylation. Now, what do you need? Now, who is your alkyl provider? In other words, who is the ethyl provider here? It must come in a halogenate alkane form. Okay, so we need things like chloroethane. Okay, chloroethane will provide the ethyl on the ring for you. And what do you need? You need AlCl3 catalyst. Okay, maybe I should put a dot on all the requirements, reagent and conditions. Another one you need is called heat. Okay, Friedel-Crafts alkylation and the subsequent one, Friedel-Crafts acylation, requires heating. Now, if you do partial question, you will come across sometimes heat is needed, sometimes heat is not needed. All right, so it depends on how early the parcel that you are attempting. Okay, so but for me now, I would suggest you put the word heat. All right, yeah. Friedel-Crafts all requires heat if you're talking about the new syllabus 2022 to 2024. Okay, so let's construct an equation for the Friedel-Crafts alkylation. So we start with the benzene ring, and then our chloroethane that provides our ethyl group, and you need a catalyst. I'll write the catalyst on top of the arrow, and then you will get your ethyl benzene. Okay, so that is alkylation. Now the last one is Friedel-Crafts acylation, number 4. Okay, let me just put here. This is called an acyl group. Acylation means putting an acyl group. So maybe perhaps I just drag an arrow here. Oops, not very nice. Okay, never mind. I'll draw the arrow later on. Okay. So, what do you need? Okay. Let me see. Yes, I have a ruler. In a moment. Okay, this is number 3. Okay, and this is number 4. Okay, I think that's neat enough, more or less, what's going on. Okay, now this is called acylation. I'll write it here. Okay, so acylation is a C double bond O with an R. Okay, so we will need an acyl chloride group. Okay, that looks something like this. Okay, so acyl chloride is C double bond OCl. All right, now you can actually change this back to your OH, okay, which is carboxylic acid, for example. Now we call this the carboxylic acid and its derivative. Okay, if not, then you can change it to an ester, OR, COOC, all right, COOH, COCl. All this belongs under carboxylic acid and its derivative compounds. You just need to change that particular. So now we're involving in acyl chloride where we put a chlorine at the right corner here. Okay, so which part is the one that's going to be attached onto the benzene ring? So a lot of students will make mistake over here. The part that you're attaching is actually this one, the acyl group. Okay, I put gray color here. You are attaching this particular part. Okay, yeah, this part. Now, so acylation, what do you need? You need a acyl chloride, okay, here, which is known as ethanoyl chloride. And then you need AlCl3 catalyst and heat. All Friedel-Crafts reaction requires heat. Okay, so therefore you attach now. Then we will also construct an equation for it. A ring plus your ethanoyl chloride with the help of a catalyst and heat. Oh, heat and heat. Then it will give you, oh, and HCl. Okay, how do we name this compound? Okay, since we already draw this thing out. All right, we call this a phenyl ethanol because the function group is a C on the ring, C double bond O, and a CH3. Okay, so this is called a phenyl ethanol. Please know how to name your product. Okay, now I have just covered the 4 reactions of the benzene ring. Now, if I were to zoom up and look at the 4 different reactions here, okay, let's look at what we have covered. You realize that step 1 requires catalyst, step 2 also requires catalyst, same goes to step 3 and step 4. So now do you understand why they require catalyst? It is due to the benzene being a stable compound. And why are they stable? Because it go all the way up here due to the delocalization of the pi electrons in the ring that gives aromatic stabilization. Okay, so today I will cover these 4 reactions, all right? And before I end the video, I will give additional bonus for the subsequent video, okay? Now, first, I continue a little bit preliminary preview. Now, chlorine is an electron withdrawing group here. Okay, and I'll put this blue. Okay, now NO2 is a electron withdrawing group as well. Okay, and then ethyl. Oh, I wanted green color. This is electron donating group. Okay, and the last one, your acyl group is an electron withdrawing group due to the C double bond O. Okay, so these are the 4 substituent or so-called electrophile that can be substituted on the ring. Okay, and the mechanism involved in this 4 reaction is known as the electrophilic substitution. So I'll write on the left-hand side, mechanism involved is called electrophilic substitution. So the next video, I will cover on what is electrophilic substitution and is step by step, okay, for the chloro, nitro, ethyl, and the acyl chloride group or the acyl group on the ring. Okay, so please memorize the 4 reactions for the condition and reagent required.